NURB curve. In history, I think I already mentioned you can control all the dimension parametrically here. For example, I want to give radius as 10, sweep 260, and the sections 8. Degree is a kind of same as a length. If you change degree to linear, it's a polygon. It's not a circle anymore. So here you can control how many sections you want. I want to give 16. So you can see more edges, 6. Okay. So this is one circle I built. Then I'm going to duplicate this circle. When I duplicate the circle, this is actually a couple of options here. I'm going to use a duplicate special. If I check this setting box, you can see duplicate special give you more options. I want to duplicate this guy with the input. The difference is if you make duplication with input, hit apply, you can see the new version I just duplicate has exactly the same history as the old one. If you don't do that, the new version you duplicate don't have the history. The reason is I have a duplication of the history, and then I can control, for example, degrade to cubic. So that guy is a circle. So I will scale that a little bit, move up a little bit. And I'm going to duplicate another one. So let's do another duplication with special and move up and scale a little bit. So you have 1, 2, 3 circles. And I'm going to surface. I'm going to create a loft. So here is a loft. If you don't want to using the toolbar, you can go to surface group, go here. You can see the loft tool. All right, so I'm just going to use the button here, loft, and then move this guy a little bit. I can use a shortcut number 5 to show the shading, right? So here is a surface. It kind of looks like a tower now. If I move this guy up, I move this guy a little bit and scale. You can see you can sort of parametrically control that geometry. So start with this kind of hexagon shape. In the middle is a circular shape. On the top is back to the hexagon. Right. So this is a parametric controlled network. In the loft, I'm going to convert the sections from 1 to 5. So you get more sections from this one. Okay. All right. So this is a pretty rough tower. I think I'm pretty happy with it. And then the next step I'm going to do is I want to do some manipulation. So first thing I'm going to do is, if you want to do this manually, you can go to Control Vertex. This is a NURB. So Control Vertex, you can pick up all the points, and then you can parametrically control this. But I want to do it with a more interesting way. I will select the entire surface. I want to do a deformation. Okay, so deformation is a tool. It's very unique. You don't see this tool in Revit or other, Rhino or CAD. Deformation will allow you to tweak or twist, deform, bend the geometry. In this case, I'm going to using a twist here. Apply to the surface. And then you can see the twist action has been executed. If I click this manipulator button here, I can see a kind of yellow color ring on the top. If I drag it, see what happened? I can easily twist that geometry. Let me use shading with wireframe. You can actually see if I twist this ring on the top, you can sort of manipulate the tower parametrically. Again, there is still a relation between these original sections. So if I scale that section, you see this still work. right? You can start to see some building looks quite familiar. Is that right? Yeah, you can actually do this in 5 minutes. All right, so we're happy with that form already. And then the next step is I want to kind of build up more details based on this rough version. So today I will show you a technique you can take advantage both NURB modeling and polygon modeling. So first, let me refresh a little bit the difference. Polygon modeling is based on vertex, edge, and face, right? They are components for polygonal shape. NURB is more like a solid model in Rhino. It's made by mathematical equations. In Maya, the name is NURB. Okay, so here I'm just going to check the setting box, and then we can take a look at options. The first option I would say is a triangle and a quads, how you want to subdivide the surface. Usually I will go with quads because it's cleaner in terms of the tessellation. And then you can control this geometry with different ways. I will start with a really simple one, is a count. Is how many faces you want to simulate this big tower. So if I use 200 as the default, hit apply. If I move a little bit, you can see here is a polygon version with 200 faces. If I do a 2000 face, okay, I pick up this guy again, hit apply, and move that. So see the difference. 2000, you definitely get more details, right? I can also do a triangle version just to compare. So here is the triangle version. All right. Also, I can do, let's not do a count. I will do a standard feet and hit apply. So here are the standard feet with triangles. Standard feet is something quite sensitive to the curvature. If this shape has a, let me just exaggerate this a little bit. Okay, you see they all update. And if this shape has a very significant change in terms of the curvatures, Maya will have more subdivision in that detail just to maintain the curvature. So that's a way you can make the surface not uniform, but had some kind of densities in certain area. Also, everything can be parametrically controlled like that way. Okay, so that is about standard feet. And then we'll do another one. Let's do a control points. Okay, so they all controlled by this original NURB surface. So if I go to this, do something manually, let's see, I can choose the points. If I scale the points, you can easily mess up actually, but you get the idea. If you manipulate, they all update. Also, I can go to the twist, right? I can click the manipulator. I can rotate again. You'll see they all update in real time. Okay, so let's go back to the stuff we actually covered a little bit last time. Is about hypergraph to show the hierarchy or the connections. The connection, you can sort of see the relation of this file. If you use Grasshopper or other program, you will know this graph is trying to tell you the procedure to create that model. So you can see I start with, let me select the curve first. Click the network. So I start with 3 curves. And these 3 curves are used to build a loft, right? So it's a NURB surface. And this NURB surface are converted into a polygon. Actually, not one, multiple polygon version, right? So each one has a relation with this original NURB. These NURB are also being controlled by the tweak and the twist. So this twist is a manipulator. You can rotate the ring, right, to twist the entire tower. So that's the whole hierarchy to build up this file procedurally. Okay, you don't have to dig into this just to, visually. This is a really good graph to show the relation between objects. Okay, so I'm really happy with the surface so far. Oh, by the way, I want to show you is in Maya you can convert NURB to polygon. You can also upstream convert polygon to sub-D and from sub-D to NURB. This is actually a little bit complex. In Maya, there are 3 types of modelings: polygon modeling, NURB modeling. Sub-D modeling or subdivision modeling is something in between. It's a half NURB, half polygon. So if you do want to transfer a polygon to NURB, you could do is convert polygon to sub-D first, and then from sub-D to NURB. But there's a lot of issues about this transition. I would rather not do that practically. Okay, so we have this nice kind of architectural glazing system right now. So next thing I want to do is I want to build some 3D structures from this tower. Okay, just to play with some ideas. There are many ways you can build a structure. Let's see. I'll just find some good examples. Build a structure like that. Okay, so I will just demonstrate some tricks to do that. So first, if I have these structures, I think this one might be a better one. I can select all the vertex, right? Because it is a polygon model, I can select vertex. So that's all the points. Make sure you switch to the polygon group when you work with polygon. Then I can use a function name, let's see, chamfer, to expand the points. So if I do a chamfer, let's see what happens. So each point are break apart into 4 points and then pushed along the connected edges. If I choose the entire object in the history, I can actually see all the actions I have done to this polygon. So this is action name is a poly chamfer, right? I just did. Click that, you can see a parameter control the width. This number you can switch between 0. If I tap 0, let's go back to original. Between 0 and 0.5, I believe. So 0.5 is push up to the end. Also, you can choose any number in between. So 0.3 is somehow in between. You got this pattern very easily from that. And if I choose the vertex one more time, maybe just the one in the middle, I will do another chamfer. So chamfer twice. Let's see what happens. See what happened? It breaks that all the points again. And what happens if I do this one more time? You got more subdivisions. Okay, so each time you do this action, is closer to a circular shape. And what happens if I select the face here? All right, then I can do a poke face to break apart that face from the center point. So this is how you tessellate a very complex structure. If I do a poke face now, it's break apart like that. So I can get interesting patterns, right, across this skyscraper. And then the next step is how I can convert that edges into a frame system or as a glazing system. Later we'll update, the whole structure will update. This can be done manually or using the Mel script. I would like to do this as a Mel script. Mel script is like a scripting language in Maya. You can customize the script. You can write by yourself. It's very similar like a Python or VB if you have some experience on that. So I'm going to download a mail script I wrote years ago. It's really useful. So I'm actually, this is a quick way. I will just go to our class website, click schedule, and then click project 2. This is the new project you guys are going to work on until the midterm. So I will just go to the project 2. In project 2, later I will go through the detail. In project 2, I had 2 links to the mail script for the skin. One is a polygon super extrude. Another is render ISO line with NURB. So the 2 mail script. I'm going to using the first one. So just one click, you will see all the code. I'm not going to talk details about the meaning for the syntax, the lines. So I'm just going to Control A, select all, Control C, copy. So go back to Maya. I will make sure in the window UI elements, actually here, display UI elements, you want to turn on the, I think it's in the time slider. Oh, it's in the command line. Wait a second. Yeah, it's right here. You see the tiny button in the command line, like a window, right? Tiny window here. So if I click, I can actually open the script editor. So the bottom part, if I Control A, I can delete, Control A, select, and then delete all the existing code. So this is a mail script. I can use Control V to paste the one I just copied. So this is all the script I can execute in Maya. To do this more efficiently, I will actually go to the custom bookshelf here. Control A one more time to select all the script, and then use middle button to drag and drop. Okay? So what happened is I create a shortcut to that mail script. I just copied and paste. So what function of this mail script? If I click, it generates a window. See, here is my name. I did that in 2007. So what this mail script will do is, if you have a polygon model, let's see this polygon model. Okay, the first value is control how much you want to create, how much scale you want to use to create a void. So now if it's a 90%, if I hit apply, you'll see the opening, the void is about 90% of that particular face. Let me undo that. I can change this to 50%, right? 0.5. If I hit apply, you will see the opening is 50% of the entire face. So you can use this to sort of control the window wall ratio, right? If you want to have more transparency, or if you want to have more opaque surface, you can control that. So I will go back to 8.8. That is a ratio I want to use. The height is actually defined the depth of the extrusion. So right now is a 0.1 negative, right? So it extrude inside with this dimension. Let me Control Z to undo. If I increase this value, let's see 0.9, hit extrude, you'll see the thickness of this framing system is bigger, right? You got a bigger dimension for that. So it really depends on the settings. I think for me, probably 0.3 will be good enough. This one I will give 0.7. So you have fully control on this process. So I got these really interesting frame structures. Again, if I go back and manipulate that geometry, you should be able to see the update right here. Although sometimes it will give you the error message. So it's better, make sure you're happy with the form first, and then do this super extrusion. So So here, if I select that shape, I can move up and down. You can see all the form, they will update. I can even select that guy. Because it's a 3-dimension frame system, let me undo first. Yeah, I do want to have a duplication for this guy. So let's make a duplication first. The reason is, after I create a frame system, I still want to maintain the original surface. So later I can use it to build the glass, right? So you don't want to losing that guy. Make a duplication is always a good idea. And for this one, I don't know, I can even do a smooth. So go to polygon. Let me save the file. It's a good idea you always save your file before you do smooth. It's very easy to crash. So let's see, tower. Later I will share this file through the depth space. Okay, so save that. And I'm going to apply the smooth. That is here. And I can increase the deviation from 1 to 2. So you start to see that very blobby, maybe 3 here. Very smooth geometries. Let me convert the shading. I will disable the wireframe so you can see the shape. Maybe I will apply a polished material. Let's assign a new material to a bling here. Right, you start to see the form like that. If I feel, well, this machine is getting kind of slow, I will go back to my smooth action. I change deviation from 3 back to 2. Okay, so you get less face. This is very important. When you manipulate a Maya geometry, it's very easy to end up with millions of face. When you do rendering, it might crash. So just make sure if the tower is far away, you don't have to bouncing up the subdivision values. Right, so I got this pretty nice tower here. And then for this guy, I will assign another material, assign a new material. I will give another bling here. I will give a color as blue. I will make transparency kind of in the middle. And I will move this one back to the structure. So you have the structure here with a blue color glass. I think I need to make a more accurate move. But you got the idea. This is how the conceptual tower can be created very quickly. So this is just one version. There are many, many ways in Maya to change the iteration. See, for example, let me do one more. I will convert this guy one more time. So NURB to polygons. I will using count. Let's do 500. I don't want to go too high. So here's another one. So for this guy, instead of using chamfer or poke face, right, I will do something else. So maybe I want to do a poke face first. I will just select a portion of the geometry, so it's easy, you can see the difference. I select this face, I will do a poke face. Right, so basically it break apart all the triangles from the centroid, from center point. And what happens if I do another poke face? You start to see this kind of crystal shape, right? Because each time it's break apart from the middle. See, I will do one more time. Right, you see that shape came out. So it's just a matter of the sequence, how you want to build the details. Or maybe after the poke phase, I want to do a chamfer, just reverse the sequence. Now you got the chamfer shape. It looks like a star now. All right. Or maybe I want to select the shape one more time, and then I can do a triangulate. So every single polygonal face, if the edge is more than 4, more than 3 actually, it will be triangulate. So if I do that, you'll see the shape is tessellate, like that fashion, right? So let me do a shading wireframe. So this portion has a really interesting pattern start to came out. Let me undo that. Okay. I can also do, I think is, let's select all the vertex. So from this vertex, I'm going to do extrude. Okay. So when you extrude the vertex, what happens is they build up a lot of small pyramid, right? And in the action history, you can see these actions is extrude all the vertex. The length is control how far they go. If I type 2, they go with 2 units. If I type 0, they kind of stay in the same place. Division I can use to build up how many loft or the rings I want to use to create this extrusion. Width I can control the, how far it go to the other end. All right, so very easily I can make the length as 1. So that's still, this is a skyscraper, right? The same idea, but it's kind of being manipulated in the different versions with these divisions. I will change this back to 2 probably. Okay, so that is an interesting way. And then I can run this mail script, create extrusion. So it kind of create that really, let me undo that. I want to make this stronger, so 0.3, maybe 7. So that created really interesting stuff here. I can also maybe duplicate, Control D, duplicate another version here. Then I can try a smooth just to see how it looks. So polygons, smooth. Let's see. Division I will increase to 2. Okay, that's actually pretty interesting. Turn off the wireframe. Okay, so that's no bumps here. All right, so this is what I think about the variation. Number one, variation can happen by manipulate original object. If you have this parametric relationship, you can still maintain that. Number two, you can manipulate the patterns. So the pattern can change, can update based on whatever actions you made. So this is the first parametric tutorial on polygon. For the NURB, let's go back to this homework assignment. For the NURB mail script, the second one, render ISO lines with NURB. I will do the same thing, Control A copy, Control C, so here. So the second mail script is only valuable when you deal with a NURB surface. So this one is actually a little bit difficult to use. You have to select, I will using this guy as example. You have to select the ISO palms of this NURB surface. ISO line is more like the edges in polygon. So here I choose ISO lines. I can select all the lines. You can see the yellow color. And then I can click this mail script. It does not have a user interface. You just select the ISO lines and click it. It automatically builds the NURB frames. So this is not a polygon. It's all based on the surface. It builds a NURB frame automatically. This mail script is come from the GSAPP Columbia, so I have to let you know it's not my script. The way it works is it put all the frames into this group. Okay, depends on how many lines you select. They are in this group. Also, you have a new object. The name is MR circle. If I have to zoom in, you can see this circle is here. This circle controls the thickness of the frame. So if I make it really fat, really thin, you can see the reaction in real time. All right, so this is kind of the same technique I did for Polygon, but if you want to maintain as a NURB, they have the similar stuff here. So for the deformation, let's try that. If I rotate this guy, I click the manipulation. This is the manipulation tool. If I drag it, oh, they actually lost the. That's interesting. They actually lost the control of that. Oh, I have two objects. Probably I accidentally yeah, I think I probably accidentally deleted the original one. So I could have two here. That's funny. This is the original, I know. This is the new one. Because the new one, if I move, nobody. Oh, there's something responding there. Okay. Let me just hide. Control H. Yeah, just refresh. Control H is a way you can turn on object. Then I can choose a twist, manipulate. It's kind of lost. Anyway, it's not a big deal. All right, so this is the NURB modeling and polygon modeling.